points on the ellipse 9x squared plus y squared equals 9 that are farthest away from the point -1, 0. Okay, so let's first get this in the proper form. So we need to divide by 9 because you want this to equal 1. So we have x squared plus y squared over 9 equals 1, which I'm going to rewrite it as y over 3 squared. Now, the ellipse has a center of 0, 0. And here, x, the denominator is 1, so we go 1 in the x direction. The denominator here for y is 3, so we go 3 in the y direction. So, this is not drawn to scale, but pretend this is our ellipse. Okay, so this is our point right here, and we want to find the maximum distance. So clearly, the points are going to be somewhere on this side. Okay. So we need to figure that out. So the way we do this is we take our point -1, 0, and let's pick a random point over here, call it x comma y. I don't know where it is exactly, but it's going to be somewhere on here. And so we want the distance to be as big as possible. So we're going to take the distance formula, which recall is x2 minus x1 squared plus y2 minus y1 squared. Now, I'm going to call x2 and y2 -1 and 0, x1, y1, x and y. So we'll have -1 minus x quantity squared plus 0 minus y squared. And that simplifies. I could pull out a negative, and I square that, becomes positive. So this is the same thing as saying x plus 1 squared plus y squared. And so if I make the inside as big as possible, that means when I take the square root, it's still going to be as big as possible. So I can ignore the square root, and I can just focus on x plus 1 squared plus y squared. Now, we were given the equation 9x squared plus y squared equals 9. I can solve for y squared and plug it in here. So remember, this is what we want to maximize. So find the maximum of this thing. This represents the square root of our distance. Or distance squared, I mean. So let's fix that. So x plus 1 squared is x squared plus 2x plus 1. And then simplify this. Gives us -8x squared plus 2x plus 10. Now we want to take the derivative because we want to maximize this. It's -16x plus 2. Set equal to 0 and get x equals 1/8. Okay, so now in our number line, you want to make sure 1/8 is a point at which it's the maximum distance. So if we look over here, pick a point less than 1/8, say 0, pick a point bigger than 1/8, say 1, plug it into the derivative, so -16 times 0 plus 2 is positive, -16 times 1 plus 2 is negative, so this is a maximum. Okay, so it's a local maximum. So we know the x value is going to be 1/8, and recall that the formula was 9x squared plus y squared equals 9. Plug in 1/8 for x. (1/8) squared is 1 over 64, so we have 9 over 64 plus y squared equals 9. Solving for y, we end up with plus or minus 9 root 7 over 8. And so we said x was 1/8, and y is plus or minus 9 root 7 over 8. So we'll write out these 2 points, and these 2 points are our final answer.